The purpose of section 1.1 is to prove the division algorithm, and we will do that in a separate video. In this video, I simply want to state the division algorithm and give you a couple of examples to illustrate how it works. So the division algorithm states that if we are given two integers a and b, where b is required to be greater than or equal to 0, then there exists unique integers q and r such that a is equal to b times q plus r, and this extra requirement that r is greater than or equal to 0, but still strictly less than b. And so one thing to note is that if we're thinking about normal division, this number q here is just our quotient, and r is simply our remainder. So let's look at how this works in the following example. We want to find the quotient q and the remainder r when negative 17 is divided by 4. So if we write this out the way that it looks in the statement of the algorithm, we are going to have negative 17 equals b, which is 4, times some quotient plus some remainder. So let's choose our quotient to be negative 4. So that's going to give us negative 16, which would give us a remainder of negative 1. So we want to check to make sure that this satisfies the statement conditions in the algorithm. So we have that r in particular must be greater than or equal to 0 and strictly less than b. So we have that negative 1 is strictly less than 4. Good. But then we have that negative 1 is not greater than or equal to 0. So this does actually, so q equaling negative 4 and r equaling negative 1 do not satisfy the conditions of the division algorithm. So we'll have to try again. This time, let's say that we've got negative 17 equals 4, and we want a new quotient and a new remainder. So why is it that the remainder on the left-hand side here was negative? Well, it's because negative 16 is strictly less, the absolute value of it is strictly less than the absolute value of negative 17. So we want to pick a quotient q so that when we multiply it by 4, the absolute value of that product is greater than the absolute value of negative 17. So let's choose negative 5. That's going to give me negative 20, and so now to get back to a negative 17, I'm going to add a positive 3. And this r will satisfy the conditions of the division algorithm. Here we have that 0 is less than or equal to 3, which is strictly less than 4. So we take our q here to be negative 5, and our remainder to be 3. And so I want you to understand the importance of what the division algorithm is doing. We were able to find two different quotients and remainders, but because of the restriction that the remainder has to be positive and strictly less than the number b that we're dividing by, we only get one solution, and that solution is unique. Let's do another example. Here, a is equal to 8,126,493 and b is 541. So this one is very large, so I used a calculator. And if you look, this is a screenshot from Desmos.com. This is a very useful website. It's got graphing, utility features, and it's a very nice, quick calculator pull up. I would highly suggest using it for any of your math coursework, and I'll be using it several times throughout this class, and so I wanted to mention it to you as an additional resource. So if you look, we see that I've divided 8,126,493 by 541, and I've gotten the following quotient below. And so I'll highlight it. It's important, and we don't really care too much about the decimal part. What we're really concerned about is the whole part. What this is saying is that if I divide this number by 541, it's going to go in, and actually, it's going to divide evenly 15,021 times, and then there's going to be some left over. So let's figure out how much exactly is left over. So if I set this up using long division from the past, what I'm saying again is that the quotient is going to be 15,021. But how much is going to be left over? So what I need to do to find the remainder here is to simply multiply 15,021 times 541 and subtract that product from the original number. So when I multiply those two together, I'm going to get 8,126,361. And then when I subtract these numbers, I'm going to get 132. So this tells me that my quotient Q is going to be 15,021, and my remainder is going to be 132. So I can write $8,126,493 equals 541 times 15,021 plus 132. And it looks like I accidentally switched my colors here from what I was using in the last slide. So I'll go ahead and correct that, because we were taking the quotient to be blue and the remainder to be purple.